Hello and welcome to Permutations with Duplication Part 2. In my first question we have 4 quarters, 3 dimes, 2 nickels. How many ways to arrange these coins? Okay, so first assumption is that the 4 quarters you can't distinguish between them, that all 4 quarters look exactly the same. And same thing with the 3 dimes. It's not as if one dime is painted red or something like that. You can't tell them apart. So what we're looking at is we're really looking at, as the title suggests, permutations where order matters, right? Because we're talking about the order of these coins. So order matters. And there's some duplication. So how do we deal with that? Well, we start off by counting how many items do we have in total? Never mind the duplication. 4 quarters plus 3 dimes, that's 7, plus 2 more nickels. So there would be 9 factorial arrangements if all of these items were unique, which they are not. So I have to account for that by dividing by how many different ways there are to rearrange. Pardon me. So you take the 4 quarters, there are 4 factorial ways to flip them around and rearrange them, but they still look the same, right? You flip them around and they're still looking at exactly the same locations. And do the same thing with the 3 dimes. There are 3 factorial ways that you can rearrange the dimes and 2 factorial ways to rearrange the 2 nickels. The nickels are easier because you kind of just flip them and that's it. There's only 2 ways. So this will correct for all of those arrangements that are technically they are different, but to the naked eye they look the same. Okay? So now all I got to do is figure this out. So I could do it if I didn't have a calculator handy. I would just break down the factorial stuff to a certain point. Okay, so I'd probably take it to there. Okay, and then you see I can take the 4 factorial over here. I can cancel these. And then this 3 factorial is 3 times 2. And then 2 factorial is just 2 times 1. So then I could go, 3 times 2 is 6. Why don't we cancel that with the 6? And then I'll divide the 2 maybe into the 8, goes 4 times. So here's what I end up multiplying together. I got 9 times 4 times 7 times 5, which turns out to be 1,260. All right, so 1,260 arrangements because of this duplication that's going on. And that's my first example done. So I'm now going to clear the screen and show you a different example that involves a map. So I'm going to draw a map. Actually, I'm going to use the little line draw thing here. Let's draw the map here. So this is supposed to be city blocks here. Okay, so here's the city. All the different little streets. So that street had a bit of an angle to it, but that's okay. Doesn't matter. It's just made up anyway. All right, there's our little street. And here's where we are. We are at point A, and we want to go to point B. The question is, I guess before I say anything else, you can only move in 2 different ways. You can move either up a block, or you can move 1 block to the right. It's the only way you're allowed to move, because otherwise you could go round and round and round and round, and there would be an infinite number of routes to go from A and B if you keep backpedaling and stuff. So you're only allowed to move up or to the right. And so the question is, how many different routes? How many routes are there to go from A to B? How many routes for A to B? All right, now let me just show you how this would look. And then I'm going to show you our approach. You could do something like this. You could go, say, 1 block to the right. So we could do an R, and then maybe you go up 1 here. Okay, so you do an up block, and then maybe go to the right, do another R, and then maybe do another right, another R, and then maybe up. Now that's certainly a legitimate route. Okay, and the order we went was we went right, up, right, up. Now I could switch this around. I could do another route where maybe I go to the right. Sure, let's start with it to the right, and then we'll go to the right again. In fact, let's go right. Okay, so, and then we'll go up and up. Okay, so that takes us all the way up to B. That's another route. Now the question is, how many routes are there? What is going on here is essentially you have 1, 2, 3, 4, 5 items or 5 choices of direction, and there would be 5 factorial of these, except there is duplication. Because it doesn't really matter when it says right, did I mean the first right or the second right or the third right? You know, I can switch the order of the rights, and it doesn't look any different. It just means right, and that's just check. I mean, that's all there is to it. So what we have here is essentially we're just rewriting these 5 letters, and we don't want to see duplication. We don't want to rearrange, say, these 2 R's or something and count it as a different route. So I have to take that into account and divide by 3 factorial, and that's for the 3 R's, how many different ways there are to rearrange the 3 R's. And I also have to account for flipping around the 2 U's, because after all, up and up doesn't look any different than up and up. But, you know, change the order doesn't actually look any different. So here's what we have to work out. So 5 times 4 times 3 factorial on the top, and I got a 3 factorial times a 2 on the bottom. Cancel the 3 factorials, and I have 20 divided by 2. There are only 10 uniquely different routes to go from A to B. Anyway, that's pretty much all there is to it. That's where I am going to stop. So we'll catch you later.